Students, let's take a look at one more such question. In this question again, if you observe, we have a quarter circle, then there is a semicircle which is not placed on horizontal or the vertical orientation. Getting on, it is inclined in nature. So you got to understand this thing very carefully, that since the semicircle is not horizontal or vertical, then finding its centroid becomes a slight challenge. Now, there is quarter circle, semicircle, and then this particular shape can be divided into two different parts. There can be one square. I'm going to get a square over here, and then we can get a right angled triangle. So let us name this particular composite shape first of all. I can observe here, I have this point O as the origin, isn't it? Then let us name this point as A. You can have this point as B. Let's take this as C. Now what I can do here is, I'm going to draw a vertical line from point B. Let us call this as D, and this point I'm going to call as E. So observe carefully, you can have here four standard shapes. There is a square, isn't it? You can have a square over here. There is a right angle triangle. There is a quarter circle. And the challenging part is the semicircle. So the things which are quite easy for us, let us work out for those things. Now since this is 40, isn't it? So it is obvious that since BD is perpendicular, OD and EB are exactly same in length. So this is going to be 40, isn't it? This is the radius of the quarter circle, which was 40. So if this is 40, this also is going to become 40. So I've got length of OD as 40. Now let's come to this triangle ABD, this right angle triangle ABD. You can observe that this radius is 40 for the semicircle, and AB, which is the diameter of the semicircle, is the hypotenuse of the right angle triangle, isn't it? So I can say here AB is the diameter and it is also the hypotenuse of the right angle triangle. Now students, observe carefully. If you observe this OE length, it is 40, then BD is also going to be 40. This is also going to be 40. If this is 40, this entire length is 80, isn't it? Length of the diameter. Length of AB is 80. So observe carefully. If this is 80, this is 40. So can you say this 40 is half of 80? So I can very well say here that BD is half of AB. Isn't it? BD is half of AB. So I can say if BD is half of AB, then this angle over here has to be 30 degrees. Side opposite to 30 degrees is half of the hypotenuse, isn't it? So this angle has become 30 degrees. Now let us say this center, the center of the semicircle, we can name it some point. So there is, let us say this point is taken as F. I will take this point as F. We have taken letters up to E. So let's take this as F. Now students, observe carefully. Let's begin with the first standard shape, or the first standard shape over here, which is a square, isn't it? So let's begin with the square. So I have a square over here. So the first standard shape is a square. Now observe carefully, this square is placed directly on the x and the y axis. So if I take the x axis here and the y-axis here, I simply need to place the square with its adjacent sides on the x and the y-axis. What's the dimension? It is 40, isn't it? So 40 units. You can also say that it is a symmetric diagram. You can have the lines of symmetry. The lines of symmetry are going to get intersected at the centroid. Let us call it as G1. So the horizontal distance is going to be x1 bar and the vertical distance is going to be y1 bar, isn't it? I know that the dimension is 40 over here. So this length I know is 40. So I mark here 40, and I know that this vertical distance is also 40 because it is a square. So the very first thing, I'll write the area. So area is going to be how much? A1 becomes equal to side square. So the side is 40. So it becomes 40 square, which is 1600 unit square. No units are given to us, so I'm going to take it as unit square. So that was A1. Let's get x1 bar also very quickly. So it is very simple. It is going to be half of 40. So that's 40 upon 2, or I write 20 units. That's x1 bar, and let's get very quickly y1 bar also. So y1 bar is also going to be what? It is going to be 40 divided by 2, isn't it? So again it is going to be 20. So both the cases, x1 bar and y1 bar is 20 and 20. So that was all about the very first standard shape, which is a square, isn't it? Now let's work out with either the right angle triangle or the quarter circle. Now students, if you observe, I know this length is 80. This angle is 30. This is 40. If this is 30, then this has to be 60 degrees. So AD is the side which is opposite to what? AD is the side opposite to 60 degrees. So I can say I'm going to get the length of AD, isn't it? So AD is going to be root 3 upon 2 times the hypotenuse, which is AB, because it is a side opposite to 60 degrees, isn't it? Side opposite to 60 degrees. So how much is the length going to be? AB is how much? It is 80. So I write here 80. So that's 2 and 80 cancels. You get 40. So answer is 40 root 3 units, isn't it? So length of AD is 40 root 3. Length of OD is 40. So if you take the right angle triangle, which is placed at a distance of 40 units away from the y-axis, can you understand? You need to exactly pinpoint the location of the diagram over here. So this right angle triangle is placed at a distance of how much? 40 from the y-axis. The base, you can say, is 40 root 3 and the height is 40. So let's draw the second standard shape, that is a right angled triangle. So I'm going to take a right angle triangle over here. So that's x-axis, that's y-axis. So let us take a right angled triangle over here. So this is the right angle triangle, isn't it? Now tell me, what are the dimensions of this right angle triangle? Then you tell where it is placed with respect to the y-axis. So you can observe it is placed at a distance of 40. So let's mark the distances over here. So I can say that this length is 40 and this length is 40 root 3, isn't it? Now this vertical distance is also 40. Now students, you can observe the name of this triangle is ABD. So let's name it A. This is D and this is B. Now for a right angle triangle, we remember that the centroid always lies at 1/3 distances of the perpendicular sides. So who are the perpendicular sides here? BD and AD. These are the perpendicular sides. So you draw lines which are parallel to these perpendicular sides such that they are at 1/3 distances of the perpendicular sides. So I draw one parallel line. So look at this, it is at a distance of 1/3 from this particular thing. So I'm going to call this as B. So let's call this value as B, and the height is H. The height is H, that's 40, isn't it? So here I've drawn one line parallel over here, another line over here I can draw, isn't it? So the intersection is going to be the centroid, that's G2. Now students, I know that this smaller length that you find over here, this length is 1/3 distance of the perpendicular side. So this is going to be B/3, isn't it? Likewise, this distance is also going to be 1/3 of the perpendicular distance, which is H over here. So this is going to be H/3. Now, this H/3 and B/3, are they X bar and Y bar for the centroid G2? You got to understand that. So you can observe that the centroid G2 is at this distance, isn't it? The distance of G2 is this one from the y-axis. So this is going to be your X2 bar, and students, this is going to be Y2 bar. So look at this. These are the distances of the centroid from the y-axis and the x-axis. So if I now want to write the area first of all, so let's write the area. So I'm going to take the second diagram, which is a right angled triangle. That's my second diagram. So let's first of all write the area. So that's half into product of the perpendicular sides, isn't it? So that's product of perpendicular sides. So the perpendicular sides are what here? It is 40 root 3 and 40. So I write 1 upon 2, 40 into 40 root 3. So you can cancel this 40 and 2. So that's 80, isn't it? So 80 into 40, 2 into, this is 20. So this is 20 multiplied with 40. So 4 into 2, that's 8. And the 2 zeros. So that's 800. So the final answer is going to be 800 root 3 unit square, isn't it? So that's your area of the right angled triangle. So this height was 40, the base was 40 root 3. You can say the perpendicular sides. So 40 into 40, so that's again going to become 1600 and divided by 2 becomes 800 and the root 3. Now there is no need to simplify this particular calculation. You can leave it here itself. So that's A2. Let's get X2 bar also. So now be very careful with X2 bar, students. X2 bar you want to tell very properly. X2 bar is not B upon 3. It is actually 40 and then plus this B upon 3. So X2 bar is going to be 40 plus B upon 3. So I can write here this is 40 plus what's B? So B is 40 root 3. So 40 root 3 upon 3. So I certainly want to do the calculation over here for X2 bar, students. I should be getting this particular value. You should be simplifying this 40 plus 40 root 3 upon 3. And likewise, I'm going to get the value over here. And let's write Y2 bar over here. We are a little bit constrained on the space. So let's write Y2 bar. So Y2 bar is directly going to be H upon 3, isn't it? So Y2 bar is H upon 3. So let's write here H upon 3. So what is the value of H? It is 40. So this simply becomes 40 upon 3. So I'm going to get this value of X2 bar a little later from now. Okay, so X2 bar I need to simplify. So that's A2, X2 and Y2. So the second diagram is also done. Now let us move on to the third standard shape, which is a quarter circle. So I have the third standard shape, which is a quarter circle. So let's begin with the quarter circle now, students. So the third standard shape is a quarter circle. Now this particular quarter circle is placed at what distances from the x and the y axis? You need to understand this very carefully. You can see that one of the radius is directly lying on the y axis. The other radius is at a distance of 40 from the x axis. So this is how you should be locating the quarter circle. So one of the radius is at a distance of 40 from the x axis and the other radius is directly lying on the y-axis. So this is how the quarter circle is going to look like. So now you can identify the radii, isn't it? So this is the radius. This is the radius and it is 40. This is also the radius and it is also 40. Now I know that for a quarter circle, the centroid lies at a distance of 4r upon 3 pi from the two radii, isn't it? It is at a distance of 4r upon 3 pi from the two radii. So let's draw two lines which are parallel to the radius such that the distances from the radius is 4r upon 3 pi. So this small distance is 4r upon 3 pi. This is the centroid. Let us call it as G3. Likewise, you can have this small distance also 4r upon 3 pi, isn't it? But is it x bar, y bar for the centroid, students? The answer is no. This is not directly x bar and y bar. You should always tell x bar is the distance of the centroid from the y-axis. So this is the y-axis, this is the centroid. So this is going to be x3 bar. So observe carefully, this x3 bar is nothing but directly 4r upon 3 pi. Likewise, if you take this vertical distance, isn't it? This is the vertical distance. This is the distance of the centroid from the x-axis. This distance is going to be y3 bar. Now you can observe that y3 bar is not 4r upon 3 pi. You know that this distance over here was 40, isn't it? So what can you tell about y3 bar? It is going to be 40 plus 4r upon 3 pi, isn't it? So now what you can do here is, let us quickly write the areas and x bar, y bar. So A3, students, is going to be, it's a quarter circle. So I know the formula is pi r square upon 4. So pi into the radius. What is the radius here, students? Radius of this particular quarter circle is 40. So pi into 40 square divided by 4. So I know 40 square is going to be 1600, isn't it? That's 1600, and then it is getting divided by 4. So that gives me 400. So this simply becomes 400 pi. Isn't it? This is 400 pi. So that's 40 into 40. You can observe this very carefully. Do the calculations very carefully. 40 into 40. So this is 4 getting divided. 4 and 40 cancels. You get 10. 10 into 40. That's 400. So that's 400 pi unit square. That's A3. Let's quickly get X3 bar also. So X3 bar is directly 4R upon 3 pi, isn't it? So there is no confusion over here. It is directly 4R upon 3 pi. So X3 bar, I'm going to write here 4R upon 3 pi. What's the radius? I know that the radius is 40 for this particular quarter circle. So 4 into 40 upon 3 pi. So that gives me 160 upon 3 pi. No need to do the simplification. You can leave the answer over here itself. 160 upon 3 pi. That's X3 bar. And let's very quickly get Y3 bar also, students. What is Y3 bar going to become? So Y3 bar is not 4R upon 3 pi. It is 40 plus 4R upon 3 pi. So Y3 bar is 40 plus 4R upon 3 pi. So I get my answer as 40 plus 4R. Radius is again 40, so that's 160 upon 3 pi. I definitely need to do the simplification for Y3 bar. So let's do it in a short while from now. So I need to get this X2 bar calculation, this Y3 bar calculation. So that was all 3 standard shapes that we have seen over here, isn't it? So let's very quickly find the simplification part also. So I have this X2 bar, which is 40 plus 40 root 3. So 40 and root 3 upon 3. So my answer, student, comes 63.094. So I can say 63.1. So this is 63.1 units. Okay, so that's X2 bar. And let us very quickly find the length of this Y3 bar also, simplification of Y3 bar. So here you have 40 plus it's 160 divided by 3 pi. So your answer is going to come 56.9765. So I'm going to write your answer 56.9765. So these are the calculations that I've done for X2 bar and Y3 bar. Now students, we have finished with what? We have so far done the calculations for the standard shapes, the square, the quarter circle and the right angular triangle. Now we need to proceed further with the most challenging part of the question, which is the semicircle. Students, now we remember for a semicircle, the centroid always lies on the line of symmetry. You should remember this particular universal truth always, that for a semicircle, the centroid is definitely going to lie on the line of symmetry and it will always be at a distance of 4R upon 3 pi from the diameter of the semicircle. So whatever the position of the semicircle is given to us, we should be least concerned about it, whether it is horizontal or it is vertical or it is inclined, as if in this particular case. So remember that you need to always draw first of all the line of symmetry for the semicircle. You need to identify where the diameter is, and from that diameter you should keep the centroid at a distance of 4R upon 3 pi. So look at this particular semicircle that you have. This is the diameter of the semicircle. Let's very quickly make the line of symmetry, isn't it? So the centroid is now going to lie on the line of symmetry. So let's draw the line of symmetry first of all. So here is the line of symmetry, isn't it? So this is the line of symmetry for the semicircle. Now I know that the centroid is going to lie at a distance of 4R upon 3 pi from the diameter, isn't it? From the diameter of this particular semicircle. So I say the centroid is here, let us say, isn't it? So this centroid is going to be G4. So G4 is the centroid of the semicircle, which is at a distance of how much from the diameter? So this is the diameter, this is the centroid. So the distance of the centroid from the diameter is going to be 4R upon 3 pi. And what's the radius that we know? The radius is 40, isn't it? The radius is 40 here. So 4 into 40 upon 3 pi becomes the distance of FG4, isn't it? So FG4, now some geometry is going to get involved here, students. You now need to pay proper attention. Your geometry must be very strong now. So this FG4 has what length? It is 4r upon 3 pi. What's the radius? Radius is 40. So 4 into 40 upon 3 pi. So that's 160 upon 3 pi. But that is the length of FG4. It is not x bar and y bar. You remember, x bar and y bar, if you want to locate, it is always from the original y-axis and the original x-axis. So this part should always and always be remembered. So students, now if you observe this FG4, if you take a look, it is going to be 160, isn't it? Radius is 40, so 4 into 40, that's 160 upon 3 pi. For simplicity purpose, you can do the calculations if you want. So I have the length of FG4. So let's draw this diagram over here now to understand and to take the care of the geometry part very properly. So I have the fourth diagram now, which is a semicircle. So I take the semicircle now. So I'm going to draw a fresh diagram because I need to involve a lot of geometry over here. So I'm going to take this x-axis. This is the y-axis that we have. We have the origin, isn't it? So observe carefully. So this is 40 over here. This is also 40. So you can take dimensions 40 and 40. And then you have a semicircle over here. That's the diameter of the semicircle. So let's draw the semicircle over here like this, isn't it? This is the diameter. And then you have the center over here. That's a line of symmetry, isn't it? So this point I have taken as F. So this is F. Then there is this G4, isn't it? So this is G4 over here. And I know that the length of FG4 is how much? The length of FG4 has come 160 upon 3 pi. So this is FG4 over here. FG4. So length of FG4 is 160 upon 3 pi, isn't it? Now students, I have taken care of this FG4, the diameter, the distance and every single thing. Now I need to locate x bar and y bar. So what is x bar? X bar is the distance, the perpendicular distance of the centroid. From where? From the y-axis. So observe carefully. This is going to be x bar, isn't it? This is the perpendicular distance of the centroid from the y-axis. So this is going to be x4 bar. Likewise, let's draw the vertical distance also, the vertical perpendicular over here. So this distance is going to be what? This is the distance of the centroid from the x-axis. So this is going to be y4 bar. So I have this x4 bar and y4 bar, isn't it? So I need this distance, the distance of x4 bar and y4 bar. Now observe carefully how this geometry is going to get worked over here. Now what I'm going to do here is observe carefully. If I locate the distance of the center, I'm going to locate the distance of the center, students, over here. Once I locate the distance of the center, the things will become slightly easier for me to get x4 bar and y4 bar. Observe carefully. Now, if you locate this center, so I'm going to draw again perpendiculars from the center over here. Look at this. This is the perpendicular that is drawn from the center. So if I draw another perpendicular again from the center over here. So let's name these perpendiculars. I'm going to name these perpendiculars as, say, FM and FN. Getting or not? So FM and FN are the perpendiculars which are drawn from F on x-axis, and I can name this point as, say, L. So that's G4L. So observe carefully. You want to focus your entire attention now on this smaller triangle that has been formed over here. Getting or not? Now, from this perpendicular again, from this point F, again, let's draw one perpendicular on the y-axis also. Let's draw a perpendicular on the y-axis also. Getting or not? So let's name this point as, say, P. I'm going to call this point as P. Now observe carefully. if I want to get x4 bar, so look what I've done. I've done a lot of geometrical work over here. I've done a lot of construction over here. From this point F, I need to first of all get the coordinates of point F. I need to find the distance of point F, which is the center of the semicircle, from the x and the y axis. So I will get the x coordinate and the y coordinate of the center. Once I get these coordinates, the rest of the part becomes very easy. I'll be telling you a little later from now. Look at this. You want to get FP, for instance, let us say. I want to get FP. So x4 bar is nothing but what? X4 bar is going to be this FP plus FN. FN is one of the perpendicular sides of the smaller right angle triangle that we have drawn over there. Likewise, if I want to get y4 bar, it is going to be this FM plus G4N. Isn't it? G4N is the other perpendicular side of the right angle triangle, and FM is nothing but what? It is going to be the y coordinate of the center. So are you realizing that getting the coordinates, getting the distance of the center from the y and the x axis is very, very, very important. So students, let's understand how to get these distances. Now, I first need to get, say, this horizontal distance PF. Now, do you know what is the entire distance over here, the total distance? Observe carefully. I know that the total distance over here is 40 plus 40 root 3, if you recall, isn't it? Look at the diagram, original one. This is 40, this is 40 root 3. So the total distance is 40 plus 40 root 3. I can get this value, whatever it is. Getting on odds, I'm going to get this value, 40 plus 40 root 3. Now, this total distance is 40 plus 40 root 3. Observe this distance over here. I know that this point is A, isn't it? This point is A over here. So, you now tell me what could be the length of AM. You want to focus properly. You want to tell what could be the length of AM. Do you remember that the angle over here, the angle A is 30 degrees? Isn't it? The angle A is 30 degrees. What is AF? Length of AF is 40 because it's the radius. So length of AF is 40. Now observe carefully. This FM is the side opposite to 30. So my attention is now on the other right angle triangle AFM, isn't it? So let's focus on the right angle triangle AFM. So in right angled triangle AFM, I can say FM is the side opposite to 30 degrees. So it is going to be half of the hypotenuse, which is AF, isn't it? So this is side opposite to 30 degrees. So that's half of 40. You get 20. So FM has come, students. Observe, FM is 20 now. So this FM has come 20. This FM has come 20. Now I need to get the length of AM also. Let's find AM. So what is AM going to be? Students, AM is the side which is opposite to 60 degrees, isn't it? It is the side opposite to 60 degrees. So it is going to be root 3 upon 2 times the hypotenuse. So AM is root 3 upon 2 times the hypotenuse, which is AF. I'll write here side opposite to 60 degrees. So I get root 3 upon 2 times of 40, which comes out to be 20 root 3. Isn't it? So the length of AM is how much? The length of AM has come 20 root 3. So AM is equal to 20 root 3. Now can we find the length of OM, students? OM, or you can say this PF, they are both same, isn't it? OM and PF are both same. So therefore I can say PF, which is OM, it is going to be OA minus AM. So that's OA minus AM. So OA, the length of OA is 40 plus 40 root 3. It's 40 plus 40 root 3 minus, what is AM? It is 20 root 3. So ultimately the length of PF, or you can say OM, is going to be 40 plus 20 root 3. So it is 40 plus 20 root 3. So I'm going to get this calculation a little while from now. So I now know what is the length of PF. Now we will focus our attention in that smaller right angle triangle FNG4, because here, students, I want to get the distance of this LM, or you can say FN. Then I will be getting X4 bar and then G4N, isn't it? Because now I have the length of FM. That will be giving us Y4 bar. So I'm going to now fix my attention. I'm going to shift my attention to the smaller right angle triangle FNG4. So now let's focus in right angled triangle FNG4. FNG4. So again, if you observe, it is going to be a 30, 60, 90 triangle. Now, how this happens, observe carefully. You can see that this angle is 30, or you can see that this angle is 60. So the immediate adjacent angle becomes how much? It is going to be 30 degrees. Either you can say this is right angle, so this is 60, so it becomes 30, or you can say alternate angle, so this is 30, this is also going to be 30 degrees. If this is going to be 30 degrees, the immediate adjacent angle again becomes how much? So this is going to be a angle of 60 degrees, because this FNG4 is also a right angle triangle. Further, you can see that G4FA is also right angle, isn't it? So that's 30, then the remaining angle becomes 60, and obviously this angle becomes 30 degrees over here. So it is not just a right angle triangle, but it is also a 30, 60 and 90 triangle, isn't it? And in this, I know the hypotenuse, who is FG4. If you recall, FG4 is written over there, it is 160 upon 3 pi. So FG4 is the hypotenuse. FG4 is the hypotenuse, and its value is 160 upon 3 pi. So let's very quickly first of all find Fn. So students, Fn I'm going to get here. Fn is going to be half of the hypotenuse, which is FG4, half of FG4, because it is the side opposite to 30 degrees. So it is going to be half of FG4 is 160 upon 3 pi. So I get my answer how much? So that's 160 and 2. It is going to get cancelled. You get 80 upon 3 pi. 80 upon 3 pi. You can write the reason here. It is side opposite to 30 degrees, isn't it? So I've got the value of Fn. Let's very quickly get the value of G4n also. So students, G4n, this G4n, it is a side opposite to 60 degrees. So it is going to be root 3 upon 2 times of the hypotenuse, which is FG4. So that's root 3 upon 2 into, what's the hypotenuse? It is again 160 upon 3 pi. So I write here 160 upon 3 pi. So my answer here is going to be 160 and 2 cancels, you get 80, and then root 3 also cancels, you get root 3 in the denominator. So it is 80 upon root 3 pi. 80 upon root 3 pi. You can write the reason over here, side opposite to 60 degrees. So now I have the values of Fn and G4n. Now students, I am going to find area, isn't it? Area, then X4 bar and Y4 bar. So now for a semicircle, let's begin. For a semicircle, I will write over here A4. It is going to be pi r square upon 2. The radius is how much? It is 40. So I write here pi into 40 square, isn't it? Pi into 40 square upon 2. So I know 40 square. How much it is? So students, 40 square here is going to be again 1600. You divide it with 2, you get 800. So your A4 is going to be 800 pi square units, isn't it? So I've got the area A4. Then I need to find X4 bar. So X4 bar, you remember, X4 bar is this PF plus Fn, isn't it? It is PF plus Fn. So what is PF? It is 40 plus 20 root 3. It is 40 plus 20 root 3. That was PF. Plus, what about Fn? Fn is 80 upon 3 pi. 80 upon 3 pi. So I'm going to get this entire calculation at once, isn't it? So that's x4 bar. Now let's quickly find y4 bar also. So let's get y4 bar. So y4 bar, students, is going to be this fm plus ng4 or g4n, you can say. So that's fm plus n g4. What was the length of fm? So if you remember, fm is 20. So I write here 20 plus ng4. So what's ng4? It is 80 upon root 3 pi. So it's plus 80 upon root 3 pi. So I'm going to get my values over here. So let's quickly find these values for x4 and y4. So I have this 40 plus 20 root 3, isn't it? And then plus, you should be very careful while doing the calculation, students. 80 upon 3 pi. So 80 upon 3 and pi. So I get my answer as 83.129279. So I'm going to write 83.13. So this is 83.13. That is, students, x4 bar, isn't it? Likewise, let's get the value of y4 bar also. So y4 bar is 20 plus 80 upon root 3 pi. That's 20 plus 80 upon root 3 and pi. So I get my answer as 34.7021. So this is 34.7021. That is a value of y4 bar. So students, so far if you have observed, we have got the values of what? A4, x4 bar and y4 bar. Have you realized lot of geometry was involved while getting the centroid of a semicircle? So this is not an easy question. Getting or not, it is a slightly challenging question because it involves a lot of geometrical part. You need to understand where to draw the perpendiculars, how to take the right angle triangles, how to get the distances, and then you should be having the basic concepts of the centroids also. The centroid is nothing but what? The distances from the x and the y axis. So you need to remember all these things while solving such type of questions. So students, so far what we have done, we have found the centroids of all the standard shapes which were involved in the question. Now we are going to proceed further to find the centroid of the entire composite shape. Students, now we know for getting the centroid of the composite shape, we have the formulas: x bar is equal to summation of ai xi upon summation of ai, and y bar is equal to summation of ai yi upon summation of ai. Now for both these formulas, I will need summation of ai, isn't it? So my first job is to find the value of summation of ai. So let's get summation of ai very quickly first of all over here. So I have these areas over here. There is a1 1600, isn't it? Then there is a2, which is 800 root 3. Then you have a3, which is 400 pi. And students, there is a4, which is 800 pi. Now here all the standard shapes are kept to get the entire composite shape, isn't it? No subtraction has happened over here. No part is removed from here. So all these areas are going to be positive areas. Further, I also knew that this entire diagram was placed in the first quadrant. So I did not have to worry about the signs of the x and the y coordinates of individual standard shapes, isn't it? So let's very quickly find summation of ai first of all here. Students, summation of ai is going to be a1 plus a2 plus a3 plus a4. So it is simply going to be what? A1 was 1600 plus a2. What about a2? It is 800 root 3. It is 800 root 3. Then plus there is a3, which is 400 pi. So I write here 400 pi plus there is this a4, which is 800 pi. So I will now need to get the summation of ai. So let's get this in a short while from now. This is summation of ai. Then I need to get x bar and y bar. So I now know the formulas for getting x bar and y bar. It is summation of ai into xi bar upon summation of AI. So I'm going to do it directly now, students. It is going to be 1600 into 20. Then you have this 800 root 3 into 63.1. So this is 20 over here, isn't it? That's 20. Then you have this x2 bar, which is 63.1. So this is the second value that I'm going to consider. Then you have this x3 bar, which is 160 upon 3 pi. So I'm just marking those values so that it becomes very convenient for us to find the value of x bar. And then you have this last diagram. This is A4 and X4 bar. It is 83.13 over here. This is 83.13. So students, I'll first get the value of summation of AI. Likewise, if I want to get y bar here, if I want to find the value of y bar, the formula is going to become summation of AI into yi bar upon summation of AI, isn't it? So we have the values of y bar. So this is y1 bar. This is 20. Then you have y2 bar. This is 40 upon root 3. Again, you mark all the values. It's a very big question. Then you have y3 bar. This is 56.9765. And finally, you have y4 bar. It is 34.7021. So let's begin with the calculations part now, students. So I'm going to get first of all A1. So let's get the value of A1 here. So we have 1600 plus 800 root 3 plus 400 pi plus 800 pi. So that is simply going to become 1200 pi. You can do some oral calculations if possible. So the answer has come 6755.55. So my answer over here is 67555.55183 unit square. That's the value of summation of AI. Now I want to do the calculation for x bar, which is summation of AI into xi. So there is A1 1600 into x1 bar, which is 20. So I write 1600 into 20. That's my first value, A1 into x1 bar. Then A2 into x2 bar, students. 800 root 3 into x2 bar, that's 63.1. So I write plus 800 root 3 into 63.1, that's A2 into x2 bar. Now let's move ahead with A3 into x3 bar. So that's 400 pi into 160 upon 3 pi. So obviously the pi and the pi is going to get cancelled, isn't it? So that is the reason I've kept that pi over there as it is. I've not done the calculation of 160 upon 3 pi. So 400 pi into 160 upon 3 pi, pi and pi cancel. So I have to do 400 into 160. This gets divided by 3. That's the value of A3 into x3 bar. Then you have A4 into x4 bar. So I now write plus A4, that is 800 pi into x4 bar, which is 83.13. I'll get some answer, students. That is the value of the numerator, summation of AI into xi bar divided by summation of AI. So what's the value of summation of AI that you have? It is 6755.55183. So let's divide it with 6755.55183. So my answer has come 51.76419998. So you can simply write it as 51.7642. So I've got my value of x bar 51.7642. So that's my answer, one of the answers. I've got the value of x bar. Now let's very quickly find the value of y bar also, isn't it, students? So for getting y bar, I now need to do summation of AI into yi. So I'll take A1 into y1 bar. So it is 1600 into 20 again, isn't it? So that's the very first value. Then plus what's A2? A2 is 800 root 3. 800 root 3. This multiplies with y2. So where is y2 bar? It is 40 upon 3. So I write this multiplies with 40 and gets divided by 3. That's y2 bar. Then students plus A3, that's 400 pi, isn't it? A3 into y3 bars, that's 56.9765, 56.9765. Then plus A3 into y3 bar and A4 into y4 bar. So that's 800 pi. 800 pi multiplies with y4 bar, which is 34.7021. So that's 34.7021. You will get some answer over here, and this answer now needs to be divided with again summation of AI, which is 6755.55183. 6755.55183. So the value that is coming is 30.98. So the answer is coming 30.98, or you can approximately say 31 units. So that's your answer for finding y bar. So students, I've got the values of x bar as well as y bar for the entire composite shape. Now, have you realized that this question was again very challenging as the previous question that we have seen? Here also lot of geometry was involved, and you need to have proper attention while getting the answer for this particular question. So students, I hope that you have understood this entire question very properly. Make sure that you practice this question by solving it in your own notebook. So students, that was all about this particular question. Now we're going to proceed ahead.